Hello, John here with the Columbia River Orienteering Club in Portland, Oregon. Our video today covers map scale. When you understand scale, you can accurately measure real-world distances from your map. Here's what you'll learn: the 3 different kinds of scale, some unusual ways to measure distance on your map, and using printed map grids to estimate distance. Essentially, a map scale is the ratio of a distance on the map to a distance on the ground. There are 3 different kinds of map scale: verbal scale, bar scale, and ratio scale. Let's have a closer look at these. A verbal scale expresses in words a relationship between a map distance and a ground distance. It's written like 1 inch equals 5 miles, or something like that. This is usually seen on maps like a road atlas, and it's not so common on topographic maps. One potential problem with the verbal scale is this: if a map is enlarged or reduced on a photocopier or a printer that's trying to be helpful, the verbal scale is going to be incorrect. The second kind of map scale is called a bar scale, also known as a graphic scale. This is a diagram that looks like a ruler that shows right on your map various real-world distances. Good bar scales will list feet, miles, and kilometers like we see here. Bar scales are helpful in a couple of ways. 1, they allow you to easily measure real-world distances on your map, and 2, they do not create errors if they are enlarged or reduced on a photocopier or during printing. For this reason, a bar scale is usually the most useful scale out of the 3. Let's look at a few techniques to measure distance with the bar scale. One way is to copy the scale bar onto a piece of scrap paper. Then you can move this paper around on your map to measure straight line distances. However, you may not always have a pencil and paper with you. A technique that's more practical in the woods is to break a twig in the exact distance of a mile or kilometer on your bar scale. Then you put the twig on your map to get approximate straight line distances. Here, the twig shows us that it's 1 mile from Devil's Dream to the top of Copper Mountain. The technique I use most of the time is my finger. Put a finger on your bar scale and find a convenient fraction of a mile or kilometer that matches the width of your finger. Here at this scale, 1 thumb width equals about 1 mile. Then alternate thumbs on your map to measure distance. This technique works much better when you're trying to measure distance along a curving line such as a trail or a stream. For a complete video on using a finger scale, see Lesson 8 in this series. However, you often don't even need to use your scale bar to estimate distance. Many maps printed by private companies and maps that you may print yourself with good mapping software like CalTopo have a 1 kilometer UTM grid printed right on the map. This is mostly used to plot or determine UTM coordinates, but is also handy for quickly estimating distances. Looking at this map and knowing the grid squares are 1 kilometer apart, we can see that between the trailhead and horse camp is about 2 kilometers. For a complete video on UTM coordinates, see Lesson 11 in this series. Many maps covering the western United States have a red grid printed on them. This grid shows the Public Lands Survey System, also known as PLS, or Township and Range. This system was created in the late 1700s to survey the undeveloped land of the western United States. It's made up of 3 components: township, range, and section. The township and range designation is shown here in the blue boxes, and the sections are marked in the red boxes. Each red square shows a section. In theory, these are 1 mile on a side. The section squares can get a little wonky in steeper terrain because running a straight survey line over a mountain range in 1830 with awkward, heavy equipment was very challenging work. But in flatter areas, you should see almost perfect squares like we do here. Knowing that each red box is 1 mile on a side lets you quickly estimate distance. Without ever looking at your scale bar, the red grid shows us the approximate distance between the marked points. The third type of map scale is called a ratio scale. This type of scale is the ratio of the distance on the map to the distance on the ground. Ratio scales are written as a 1, and then a colon, and then a big number after that. A good way to think of a ratio scale is the larger the number on the right, the more zoomed out the map will be. And conversely, the smaller the number on the right, the more zoomed in the map will be. All of the continental U.S. is mapped at a scale of 1 to 24,000 by the US Geological Survey. This means that 1 unit of anything on your map, a centimeter, an inch, a pine cone, whatever, equals 24,000 of those same units in the real world. It's important to keep the same units on both sides of the colon. A common mistake is to say 1 inch equals 24,000 feet. Nope. If you have 1 inch on the left, you have 24,000 inches also on the right. Now, knowing that 1 inch on your map equals 24,000 inches on the ground is actually pretty useless for most people. To make this ratio scale helpful, you have to do some math, and it looks something like this. Yuck. That's right. Not much fun, especially when you're on a hike. So using a ratio scale in the US is generally not very useful. And just like with the verbal scale, measurement errors can happen if a printer or a photocopier enlarges or reduces your map. Fun fact break. What 3 countries of the world do not use the metric system? Yes, Liberia, Burma, Myanmar, and the USA. I'll leave it at that. Ratio scale is much more useful if you can think metric. We're going to get into a little math here, but stick with me, it's pretty easy. Let's say our map has a ratio scale of 1 to 100,000. This tells us that 1 centimeter on the map equals 100,000 centimeters on the ground. You hopefully know that there are 100 centimeters in a meter and 1,000 meters in a kilometer. If we count the zeros in both 100 and 1,000, we see that there are 5. So to convert ratio scale to kilometers, move the real-world decimal point left 5 places. In this example, the real-world half of the ratio is 100,000, so moving the decimal point left 5 places deletes the red zeros and leaves us with 1. So a ratio scale of 1 to 100,000 means that 1 centimeter on the map equals 1 kilometer on the ground. Okay, now you try a couple. If the ratio scale is 1 to 1 million, 1 centimeter on the map equals how many kilometers on the ground? We move our decimal point left 5 places, removing the red zeros, so that gives us 10 kilometers. Let's do one more. If the ratio scale is 1 to 50,000, 1 centimeter on the map equals how many kilometers on the ground? Again, we move our decimal point left 5 places, so that gives us 0.5 kilometers or 500 meters. You get the idea. If you think metric, ratio scale becomes a lot easier to use. Let's apply this to a real map. Here we have a ratio scale of 1 to 100,000. On our map, we measure 3 centimeters between points. This gives us a real-world distance of 3 kilometers on the ground. To measure centimeters on your map, use a centimeter ruler that's hopefully on the base plate of your compass. You may hear maps referred to as large scale or small scale. A large-scale map, such as 1 to 24,000, is zoomed in and shows more detail in a small area. Conversely, a small-scale map, such as 1 to 250,000, is more zoomed out and shows less detail over a large area. A 1 to 100,000 map is sort of in the middle. If you're feeling a little dyslexic right now, you are not alone. These terms definitely can be confusing. Having maps of various scales can be helpful on a backcountry trip. You might use a 1 to 100,000 map for the approach hike and then change to a 1 to 24,000 map if you're traveling off-trail in more technical terrain. If you buy a printed map, the scale is fixed and you can't change it. However, good mapping software like my favorite, CalTopo, lets you change the paper size and the ratio scale to customize a map to just about any size and scale that you want. I've made a detailed tutorial video on using CalTopo. Give a YouTube search for Columbia River Orienteering Club to find our channel and see it. Keep in mind that the paper size you choose changes the total area covered by a given map scale. For example, if you print a 1 to 24,000 map on 8.5 by 11 paper, it'll cover about 3 by 3.5 miles. If you buy the same scale map, 1 to 24,000, but it's printed by the US Geological Survey on a bigger poster-sized sheet of paper, this map now covers 6 by 7 miles, or roughly 4 times the area. If you want a zoomed-in, large-scale map on 8.5 by 11 paper, you may need to print different sheets to cover your entire trip. Here's an example showing all three of the scale types that we've talked about. The verbal scale is not very helpful because the miles and kilometers are not nice round numbers. The bar scale, as we mentioned, is probably going to be the most useful. And finally, the ratio scale. Again, it's sort of an odd number, so it probably won't be too helpful, but still it's in there. Well, let's summarize what we've covered today. You now know about the three different kinds of scale, how to use twigs, fingers, and grid squares to estimate distance, what a large scale and small scale map means, and now you're ready to measure distances on any map you use. Thanks very much for watching, and please give us a like and a happy comment on YouTube if you found this video helpful.